New features in TINACloud. Welcome to TINACloud, the online version of TINA Design Suite. TINA 14, and its online version, TINACloud, is a major upgrade with plenty of new important features. Let's see the most important ones. New components. Lots of new analog, digital and mixed signal components are available from various manufacturers including ADCs, DACs, microcontrollers, voltage references, gate drivers, DC-DC converters, sensors and more. TINACloud also has a variety of new analysis modes. Multisine simulation, Piecewise linear PWL solver, new RF components and their analysis, Circulator, 3 and 4 port directional couplers and more. User-defined Fast Analytic solver for SMPS and other devices in both Interpreter and Python. 7 HDL Languages, VHDL, VHDL-AMS, Verilog, Verilog-A, Verilog-AMS, SystemVerilog, System C. And this isn't all. TINACloud also has faster solution algorithms, inverse Laplace transform, full Python programming language for additional calculations, post-processing and more. Python support in the design tool, DC-DC converter application circuit search. You can also learn more about TINACloud from the new TINA and TINACloud ebook, 440 pages with tutorial videos. TINACloud runs on most operating systems and computers, including PCs, Macs, thin clients, tablets, even on many smartphones, smart TVs and ebook readers. Let's look at some of the features in more detail. Multisine simulation. Multisine analysis calculates the frequency response of circuits, without linearization, using transient analysis with a special excitation, consisting of multiple sinusoidal, so-called multisine, voltages. This is especially useful with SMPS circuits, where AC analysis is only possible through special, so-called average models which cannot be automatically created, and for which, manual creation is quite laborious. In addition, multisine simulation is close to the real-life multisine measurement of transfer functions. Let's see an example found in the multisine folder of TINA examples. Select AC multisine analysis. In the AC multisine analysis dialog, among others, you can select the required diagrams, and set the steady-state time, from where the multisine excitation is added. 3 diagrams will appear. Transient result with multisine excitation from 1.5 millisecond. Circuit response to multisine excitation. You can zoom in to see the circuit response in more detail. AC transfer amplitude diagram. Bode diagram. Piecewise linear, PWL solver. In addition to the SPICE solver, TINACloud also includes a piecewise linear, PWL solver. A unique feature of TINACloud is that in PWL mode, it automatically creates the PWL models from semiconductor and other nonlinear SPICE models. This provides an up to 10 times faster solution depending on the structure of the SPICE models. You can find examples of PWL analysis with explanations in the PWL folder of TINA examples. The solver for PWL analysis can be selected in the options dialog of the analysis menu of TINACloud. PWL analysis is also very useful for multisine analysis, as it shortens the transient analysis included in multisine analysis. To demonstrate the effectiveness of the PWL solution, let's load a startup transient example from the PWL folder of TINACloud. You can choose Newton-Raphson or the PWL solver in the options dialog of the analysis menu. Compare the result and execution time of both solutions on the screen. In this case, the PWL solution runs 4 times faster. Note that the simulation time may also depend on the server and its workload to which you are connected. New RF components, Circulator, 3 and 4 port directional couplers. There are several new microwave components in TINACloud. Circulators are defined with main parameters, or with detailed manufacturer provided or measured as parameters. 3 and 4 port directional couplers can be defined similarly with main parameters, or with detailed manufacturer provided or measured as parameters, in touchstone format. Here is a sample of the manufacturer-provided S-parameter file in touchstone format. Let's see an example. VSWR, voltage standing wave ratio measurement, using the CP20408A10 4-port directional coupler defined with a manufacturer-provided S-parameter model. User-defined Fast Analytic solver for SMPS and other circuits in both interpreter and Python. For a wide range of power circuits, it is possible to obtain a fast, approximate analytic solution using either Python or the TINACloud interpreter. If an analytic solution is available for the circuit in the design tool, it is possible to obtain the results quickly as diagrams by running the Fast Analytic Solution command from the Analysis menu. You can also customize, refine, and apply the available solutions to similar circuits, or even create your own, to better suit your specific requirements. Fast Analytic Solutions with Python. When you select the Fast Analytic Solution command from the Analysis menu, the program will create steady state, start-up transient, AC Bodhi, and efficiency diagrams of the circuit. You can also obtain the same diagrams in the design tool. In this example, the program code is in Python. When you press the Run button, the program will create the same steady state, start-up transient, AC Bodhi, and efficiency diagrams of the circuit. Let's see the same solution with TINACloud's interpreter. The program code is written in TINACloud interpreter. New HDL languages in TINACloud. 2 new hardware description languages, SystemVerilog and VHDL-AMS, are available. With these extensions, there are 7 available HDLs, in addition to SPICE. SystemVerilog. SystemVerilog is an extension of the Verilog hardware description language, also included in TINACloud. In TINACloud, SystemVerilog is automatically translated to System C, which can be compiled with MS Visual Studio, providing a very fast and optimized code. You can find several circuit examples in the TINA Examples, HDL, SystemVerilog folder of TINACloud. Let's load a wave generator circuit in which a digital waveform is created with SystemVerilog. Note that the code in the macro is written in SystemVerilog. Let's run a transient analysis. Out shows the generated signal after ADC. The great advantage of TINACloud is that you can run HDL languages together with SPICE. Let's change the switch and see the waveform after the low-pass filter with the SPICE op-amp macro. Note that the op-amp macro is written in SPICE. Run transient analysis. Now, out is a smooth sine wave. VHDL-AMS. VHDL-AMS is an extension of the VHDL hardware description language, also included in TINACloud. It includes analog and mixed signal extensions, AMS, to the purely digital VHDL language, in order to simulate analog and mixed signal systems. You can find several circuit examples in the TINA Examples, HDL, VHDL-AMS folder of TINACloud. In this circuit, the same sawtooth wave is generated with 2 different circuit sections and methods. In the upper part, the counter is written in Verilog. In the low-pass active filter, the op-amp is written in SPICE. The lower part contains a VHDL-AMS block that generates the same waveform. A great feature of TINACloud is that it can run all HDL codes in SPICE as well as MCU codes together. Inverse Laplace transform. You can define linear circuit components with Laplace transform, voltage sources, current sources, transfer functions, and more. Now these components can be used in both the time domain, using inverse Laplace transform, and in the frequency domain. You can find examples in the TINA examples Laplace folder of TINACloud. Let's demonstrate this through a simple RC integrator circuit. In the Laplace subcircuit, the transfer function of the RC circuit is given with the standard SPICE Laplace function. Run transient analysis. The upper curve shows the result of the numerical solution of the state equation of the circuit, while the lower curve shows the result of numerical inverse Laplace transform. The two methods provide the same results. Embedded full Python programming language in TINACloud for additional calculations, circuit design, and more. In addition to the interpreter, the Python programming language is also available in TINACloud. Python is a modern, high-level, general-purpose programming language with extensive libraries and a lot of free programs available for various topics that can now be used in TINACloud. You can find use examples in the TINA examples, Python and TINA examples, design tool folder of TINACloud. To get started, TINACloud includes Python shell with a short bubble sort sample program to play with. Analyzing an RC circuit using Python. In this example, we will draw the body amplitude and phase characteristics of the RC circuit on the screen using Python. Python support in the Design tool. Design tool is a unique and powerful tool in TINACloud that works with the design equations of your circuit to ensure that the specified inputs result in the specified output response. The tool offers you a solution engine that you can use to solve repetitively and accurately for various scenarios. The calculated component values are automatically set in place in the companion TINACloud schematic, and you can check the result by simulation. This feature is also very useful for semiconductor and other electronics component manufacturers to provide application circuits along with the design procedure. Now, you can add design procedures to your design using the standard Python programming language as well. You can find application examples in the TINA examples design tool folder of TINACloud. Let's see an example. The output voltage of this circuit is 9 volt. Now, let's specify output voltage as V out equals 5 volt. In this design, the design procedure is described in Python. You can modify or write a new one. Press the blue Run button. The program will draw the calculated steady state, start-up transient, body, efficiency diagrams, and the redesigned component. Now the output voltage is the specified 5 volt. The redesigned value of RFB1 is 5.25 K. You can save the redesigned component values to the circuit by pressing the OK button. Enhanced with these new features, TINACloud can help you even more to advance your ideas and your product definition. That wraps up our summary on the new features delivered with TINACloud and its offline version TINA 14. For more information, visit our websites, tina.com and tinacloud.com. Visit our YouTube channel, youtube.com/user/TINA Design Suite.